Alright class, today we're going to do the lady and the lamp problem. This is kind of a famous problem, and it usually involves somebody walking either away from or toward a street lamp. And of course if they're walking toward, the distances and rates should be negative. However, here, since all the rates are the same sign, we typically don't care whether we use positives or negatives. So I have a problem from the Sacred Book, which is the James Stewart 4th edition. And I'll read it to you because I know the print's kind of small. It says, the street light is mounted at the top of a 15-foot tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of his shadow moving when he is 40 feet from the pole? Alright, so let me just copy down the most important stuff from this problem. So the street pole is 15 feet tall and the man is 6 feet tall. We're pretending it's a lady though, okay? And he's walking away at a rate of 5 feet per second. Okay, so let me get this thing out of the way. Some of the things that really confuse people with this particular problem is when you're talking about these distances, which distance is what? So there's actually three of them that are going to be important here. There's this distance, which is the distance from the person to the pole. Okay, and that's x, so from the base of the pole to the person. And then y, that's going to be the length of the shadow, not the tip of the shadow, as they asked for in this problem. So this distance here, z, that's going to be the distance from the pole to the tip of the shadow, so it's going to represent the point where the tip of the shadow is moving. And that's the one we're looking for here. Okay? We were told how fast this person's walking, so that's going to be related to how fast x changes. So dx dt is 5. Okay? And of course, if the person was walking towards the street pole, it should be negative, but it doesn't really matter. Once again, all the signs are going to be the same here, so we don't really care that much. Of course, we know that x plus y is equal to z. And then what we do is we use similar triangles. So we've got this big triangle here, and it's got a height of 15 and a length of z. And then we got the little shadow here, and it's got a height of 6 and a length of y. And so if we just cross multiply here, we get 15 y equals 6z. Of course, you know, at any point here you could really take a derivative, but we're gonna sort of get it to where it's nice and easy. Okay, so we have y and z. We don't have x, which is the rate we do know. So we're going to have to solve for one of these two. And since we're asked about the tip of the shadow, we want to know what dz dt is. So it'd be nice if we had x and z. So that means what we'll do is come over here and we'll solve for y. Y is z minus x. Okay, so we'll substitute that in for y. So 15 z minus x equals 6z. And then when we multiply this out, we're going to get 15z minus 15x equals 6z. And then when we solve for get z's on one side and x's on the other, we'll get 9z equals 15x. Okay, at this point, we're actually ready to take a derivative. So when we take our derivative, we're going to get that 9 dz dt equals 15 dx dt. And when everything sort of settles out here, so when all is said and done, dz dt is going to be 5 times 15, because 5 is dx dt, and then all that divided by 9. That's 75 over 9 feet per second. Okay? So this is how fast the tip of the shadow is moving. And if we want to know how fast the length of the shadow is moving, of course we could do something similar where we have replace z with whatever it is, x plus y, and do all this mess again. Or we could realize that we've already done all the work And up here we would know that since y is z minus x, dy dt would be dz dt minus dx dt. Okay, and then knowing that, we just substitute everything in. And dy dt would be 75 over 9, that's dz dt, minus 5, and if we get a common denominator, that's going to be 45 over 9. So that's going to be 30 over 9, or 10 over 3 feet per second, and that's the length of the shadow. And pretty much every problem that's like this may have different numbers. They typically always tell you what x is. So here they said he was, what, 40 feet away from the pole? It's irrelevant. I mean, it would matter maybe if we replaced the y over here in the denominator and took a derivative and used the quotient rule, but that makes everything way more difficult than just solving for things. So there you have it. There's the solution of the lady and the lamp problem. Good day.